component, I mean the continuation of the component properties videos. So this is going to be the third videos. So whenever we are going to talk about components, so there are associated properties for that particular component. Okay. Now we are going to talk about the layout and codes. First, the layout. Layout is very significant whenever we are configuring any particular component. So what layout is? So layout is where the component is going to run. Okay, where the work related file for a particular component is going to be residing. Okay, while runtime. So this is decided by layout. So you have to think and choose, whenever you specify the layout of a particular component, where you want to, what is the depth of the parallelism. So how many parallels you are going to run that particular component, okay, while processing, and where the data related files, work related files, not data related, work related file is going to be placed, okay. So for input and output data sets, the layout is not going to be displayed because the layout is uh, where the particular data set is there. Okay, that is going to be the layout for a particular input and output. Let's say we are talking about input file. So what is the layout of the input file? Whether it is a serial or multiple file, so that file itself is a layout. Okay? So the data set itself is a layout. So we don't have properties like layout for a particular input and output, or a input table or a output table. Okay. So input table and output table there will be because in so it depends. I mean, how many parallels you want to because it's an external entity, right? Table and all. So if you want to connect to Oracle, so and we want to make it multiple ways. So depending upon the node, you know. So there are things actually. So for the input file and output file and lookup and intermediate file, the layout is not going to be there now. So let's switch on to the document which I have prepared. Okay. Yeah. So okay, this is one component. Okay, the layout. So depth of parallelism, where it runs, and So what is the meaning? So whenever you create the graph, right? So sometimes you have depth as specified as 1, 2, and like that. So that is definite that this is going to be a serial or a how many way parallels. If it is a 1, then it is a serial and one way parallel. Or if it is a, let's say 5 or 6, then 6-way parallel. This component is going to be run. That number is going to be displayed over the component. Now, if it is L1, so whenever you design the graph and in initial stages, and we L1 is displayed. It could be displayed in one component, or it could be displayed in multiple components, L1 like. So the meaning of this is uncalculated layout. So the layout is not calculated yet, and the layout is going to be calculated at runtime. So this is the meaning of these kind of things, L1 or L2. The serial layout, but it is not calculated. I mean, not a serial. This is a layout number 1, which is not uncalculated. If there is a similar layout which is not calculated elsewhere, I mean another component, then the label of that component 2 is going to be displayed as L1. Also now, if L1 star, then the meaning of this is going to be propagated layout. Since meaning is this layout is going to come from neighboring component, okay, whether it is an upstream component or a downstream component, okay, but it is going to be coming from the neighboring layout. So the fixed could be 1 star, okay, 1 star in the sense of this serial layout is going to be coming from the neighboring layout, and if it is a question mark, then this is undefined layout. We did not specify the layout properties of the particular component. So we have to, this is a yellow cues would be coming. So we need to specify the layout of the component. Then the yellow cues would be displayed. I mean the warning and all. Now layout source. So whenever you see, I have chosen this. Okay, this is an input reformat I have taken up. Okay, reformat components, and there are within other properties there is a layout properties of the reformat component. So what is the layout source? So it could be coming from neighbor, propagate from neighbor. It could be a particular component, other component. It could be a URL, URL in the sense of multi M file, or it could be SDFS URL, cloud URL, or dynamic layout. Okay, in the sense of Yarn and Kubernetes. Okay, and database. So these are the multiple ways how the source would be coming for a layout. So let's see here in picture. This is the reformat component. If you specify this propagate from neighbor, then propagate from neighbor is the layout is going to be coming from the upstream component or downstream component. Okay. So it will be depending upon the by default configuration of your reformat components. So it probably could be coming from the upstream component. Or if you specify the component, particular component, if you want to make this graph, make the layout as a somewhere, let's say some other subgraph, there is a component. If you want to specify that component name, then you can select this component and you can select. There will be a drop down. All the components of the graph will be displayed in that layout and in the drop down, and you can pick and choose a particular component. Okay, and then if the layout of that component would be become the layout of this your component, this reformat component, and then you can select the URL in the sense of, if it is a serial, then I can select file and the directory location or a file location, and if I multiple, then M file colon and that directory location or a file location, or if it is SDF as a URL, then SDF as a colon and that SDF is host and location. Okay, and if it is a cloud, then likewise. Okay, similarly I can select. Most of the cases for a working layout, we don't recommend to use the cloud layout, because we just use the data from the cloud. We don't want our graph to be processed at cloud, because the communication between our server and the cloud would be very slow. Therefore, we don't use the working layout of a particular abinitio component, which is supposed to be running in abinitio locally. We don't use the layout, remote layout, like cloud layout. But if it is a case of SDFS and or node, ab initio is installed there in SDFS node, then we could use that SDFS layout for a particular component. Okay, and similarly for Yarn and Kubernetes as well. So that Kubernetes and Yarn, they dynamically pick and choose the URL. So that's a different case. Okay, so depending upon the availability of the resource, they are going to be using the or choosing the layout. So dynamically, okay, and we can build the custom layout. Okay, we need to pick and choose custom, go to edit and create the custom layout, in the sense of I could specify a number of serial files to create at a n-way multiple layout. Okay, let's say I want to run this component, as a 4-way or 8-way. I could specify 8 times a particular serial files while choosing the custom, and go to the edit and specify one by one 8 serial files. So in that case, my layout is going to be 8-way multi-way, like. Okay, and also again there is a host. If you are dealing with multiple hosts, like heterogeneous environment you are going to configure for your ab initio processing, then you can pick and choose the host, and you can go to the particular host. You can specify that that particular path, or could be multiple hosts also. Okay, and the database. So normally we don't use the database for reformat. So the database is mostly used for Oracle and SQL unloader, load and unload. So if I have a input table component, then I can pick and use the database. So whenever I pick and choose the database, what is the meaning of that is, so the DBC configuration file, there is a DB node properties. So the DB node parameter would be deciding the particular layout of the input table component, okay, or output table component. So if you specify database, then it will be also depending upon the DBC configuration file. What is the host? No, the layout of that host is going to be used as a layout of your input table or a output table. So this is what we have talked about, the layout of different components. Okay, and also we have covered the another parameters, and we have covered the layout, and we have covered the, no, we did not cover the port. Okay, so layout is covered. Okay, how the layout is there. Okay, so it can be propagated from neighbor. Okay, we can make this layout coming from the neighboring component. Okay, the ports. So if you look at the port, right, so there could be a input and output. So for a particular component, there could be input and output parameters. Sorry, input and output ports, and there could be reset ports, and error ports, and log ports, and unused ports, unused 0, 1. You know, and for some other component, there could be other different ports as well. So normally we will have input parameter, input port, output port, reset, log, and error port. Okay. So if you look at the pictorial, right? So if we want to space, there will be a different properties for a particular port, right? So this is the different. This is the, I think this is the output file. I think, yeah, output file. So in output file, there will be a port called output. Okay, only one port. Okay, so in that port, we will have different properties, right? Propagate from neighbor. Okay, and use another port in graph, use file embed, or there is another property, propagation. This property is record from format source, where the record format is going to come from, and this is propagation behavior. So if I specify propagate through, okay, if it is output file component, then propagate through is it's not going to be displayed, because there is no meaning of propagation through. Propagate through for a output file. Okay, but if it is a reformat component, okay, I think I didn't do the picture of this, but if it is a reformat component, then propagation through would be there. So if you select the propagation through in the reformat, then input port would be as it is copied to the output port. Okay, so that is the meaning of the propagate through. Meaning we are not modifying the DML as such. The record, we are not going to modify the record, though we are processing from a reformat component or any other transformation component, but we are not modifying the data. We are not specifying, or we are not dropping the field. We are not adding the fields. We are not doing any other things. Okay, so we can say that we propagating through. We are not going to define any DML over here for this output port. We just propagation through. Okay, so if propagation through is there, then there is no meaning of these propagate from neighbor, another port in graph, and all these properties are overridden by propagate through. Okay, but if it is unselected and we are checking that propagate from neighbor. Okay, so if we are selecting the, let's say we are talking about output port component. Okay, output port component for a output table. So then propagate from neighbor meaning what is the downstream component? The DML of the downstream component is going to be used over here also. Right? That is the meaning of output from neighbor for a output table or output file component. Okay. Now, if we are configuring the reformat component, and if we are configuring the output port of the reformat component, and we are choosing that propagate from neighbor, then if we have a downstream component also and if we have an upstream component also, then for the reformat component output port, the propagation from neighbor, meaning the downstream component port would be the read port of the downstream component would be the neighboring port. Let me repeat. So if we are using the let's say reformat component, okay. If we are using the reformat component and if we are using the output port of the output port we are going to configure, then and we have a let's say downstream component as a join component, let's say, and we have some input port of it, okay. Input port configure input port of join. So we are configuring output port and we have another, let's say sort. Sort is there before reformat, okay. And we have output here. Output port of sort, okay. Output port of sort. So it's very easy to understand because if we are configuring output port, then neighboring component downstream component would be there. And if we are in the reformat component, if we are configuring the input port, then propagate from neighbor, meaning the output port of sort component is going to be propagated into the input port of reformat component. So this is the neighbor. So both the ends, the neighboring would be one for output there will be downstream component, for input there will be upstream component. So this is simple way to understand. And we can pick and choose the another port in graph, right? We can use any other component which is there in the graph, that also can be selected. Or if we want to specify the DML into some file, then also use file can be done. Or if you want to embed that DML or port, you want to embed it, then you can pick and choose the embed. Okay. So this is how propagate from neighbor and propagate through works basically. Okay. So most of the component the propagate through will not be there. Okay. And the component like concatenate, and gather, all these components they are already propagate through because they don't have transform, right? So this is propagation through is significant when you have a transform graph, transform component like reformat, join, scan, roll up, all these components which can transform the data in the flow. So therein, the propagate through property is significant. So that is important in those cases. Okay. So yeah, we need to carefully configure these parameters basically. So I think we have covered two more properties of port and layout for a particular component. So thank you so much. We are going to talk. We are going to create one more video. Okay. So therein we are going to talk about the conditional property. Okay, because it's an important. So many a times we have to disable a particular component or disable a flow. So on those cases, we are going to see the use cases of those conditional graphs actually. So this is why I am creating this video is because it will cover the conditional properties of the particular component and also the conditional graphs. So this will eventually will allow us to create different conditional graphs depending upon the requirement. Okay, many a times we don't want to run a particular part of the graph or a subgraph or a particular component. So in those cases, we want to utilize the conditional properties of a particular component or a subgraph, okay, and use this in our architecture of the graph. So with that, thank you so much. Please subscribe my channel and